In this question, a scientist wants to determine how many moles of niobium ions, Nb3+, could be used up by passing a steady current of 179 amps through an electrochemical cell for 1,190 seconds. So that's our question. Our goal is to figure out how many moles of niobium ions, Nb3+, will be formed. We've been given the chemical equation here, showing what's going on in the electrochemical cell. Our first step is figuring out how much charge passes in 1,190 seconds. Let's head to our reference sheet. Here's our equation for charge and current. Q equals IT. Q equals IT. So charge equals current times time. We've been given the current here, it's 179 amps. And we've been given the time here, it's 1,190 seconds. So our equation's already rearranged for charge Q, so we can go ahead and just put in our numbers. The current, I, is 179 amps. The time, T, is 1,190 seconds. When we put that into our calculator, we're going to get an answer of 213,010 coulombs. So we can go ahead and fill that in over here. Awesome. Okay. So we've got the amount of charge. We're going to be using that in our dimensional analysis table down here to convert into the moles of niobium ions, Nb3+, that used up. So I'm going to fill that in this first box here, 213,010 coulombs of charge. Now we're also going to need to know how many moles of electrons are transferred when 1 mole of niobium 3+ ions are used up. So we're going to do that by writing the half reaction involving niobium. So we're starting with niobium 3+ aqueous. So that's going to be on the left. And we're ending up with niobium solid. So right now we have a charge of 3+ on the left and a charge of 0 on the right. So to balance that out, I can add 3 electrons on the left. So now our charge is 0 on the left and 0 on the right. So we can fill that in now. So how many moles of electrons are transferred in 1 mole of this half reaction? Well, we've got 3 electrons for every niobium 3+ ion. So 3 moles of electrons per mole of this half reaction. That means for every 1 mole of niobium 3+ ions, we need 3 moles of electrons. So that's going to be our conversion factor that we can use later on in this question. Now we can go ahead and use our dimensional analysis table to figure out how many moles of niobium ions are used up. So we're starting with charge here. And we want to end up with moles of niobium 3+. And to get from charge to moles of niobium 3+ ions, first we're going to convert into moles of electrons. Because we know how to convert between charge and moles of electrons, and then we know how to convert between moles of electrons and moles of niobium 3+ using that conversion factor we just found. Now to convert between charge and moles of electrons, let's head to our reference sheet. Here's the Faraday constant. It tells us that 1 mole of electrons has a charge of 96,485 coulombs. So in our first column of our table, we're going to be converting from coulombs to moles of electrons. So we're going to have coulombs on the bottom, so that will cancel out, and moles of electrons on the top, since that's what we're trying to get into in this first step. Then we can fill out 1 mole of electrons on the top and 96,485 coulombs of charge on the bottom. The next column is where we're converting from moles of electrons to moles of niobium 3+ ions. So we're going to need moles of electrons on the bottom, so that will cancel out, and moles of niobium 3+ ions on the top, so that's what we'll end up with. We already found that 1 mole of niobium 3+ reacts with 3 moles of electrons. So there's our dimensional analysis table ready to go. Now all we need to do is multiply everything on the top, multiply everything on the bottom, and divide top by bottom. The coulombs are going to cancel, and the moles of electrons are going to cancel. That gives us 213,010 multiplied by 1 moles of niobium 3 plus, divided by 96,485 multiplied by 3. So if we go ahead and put that into our calculator, we're going to get an answer of 0.736 moles of niobium 3 plus ions. So let's go ahead and fill in the answer here. 0.736 moles of niobium 3 plus ions. Awesome. So in this skill, we're using the dimensional analysis table to figure out how many moles of a substance will be produced, or to figure out how much current or how much charge or how much time we're going to need in order to produce a certain number of moles of something. This is the map we're going to be using. We're going to be going from charge to moles of electrons to moles of the thing we're trying to find, or the other way around, moles of thing we're going to try to find to moles of electrons to charge. We're also going to be using Q equals IT to convert between charge, current, and time. For our conversion factors, we've got Faraday's constant, which tells us the conversion between 1 mole of electrons and coulombs. And then we're going to use a balanced half equation for that element to figure out the conversion factor between moles of electrons and moles of the thing we're trying to find.